This lesson is on 6.2, which is the trigonometry of right triangles. This should be a basic review lesson for you guys in this class, so I'm going to go pretty quick. So first off, we need to see this triangle here, right? And if this is theta, if this angle is theta and that's the angle that we're looking at, then the side opposite that angle is called your opposite side. The longest side is called your hypotenuse, and the side that's next to that angle is called your adjacent side. Right? Everybody understand that? Everybody know that? And here are the 6 trig functions aligned to that. Okay, and remember this acronym, SOH CAH TOA. Okay, so where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And the reciprocal ratio of sine is cosecant, which is SCS or CSC. And the reciprocal value of cosine is secant, and the reciprocal value of tangent is cotangent. All right, so they just flip it, right, to get that. So let's find the trig functions of these guys here. Okay, so in the blue triangle, it's a 3, 4, 5 triangle, right? And we're going to get the sine of theta, cosine of theta, and the tangent of theta as well. So in order for us to figure that out, the side opposite that angle is called your opposite side. Your longest side is your hypotenuse, and the side that's next to that angle is your adjacent side. So theta, sine of theta is opposite over hypotenuse, which is 3 over 5. Cosine is adjacent over hypotenuse, which is 4 over 5. And the tangent is opposite over adjacent, which is 3 over 4. Okay. So in order for us to figure out the reciprocal values, cosecant, secant, and the cotangent, we can use the hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite to figure that out. Or we could just flip the sine value to get cosecant. So that's 5 over 3. That would be 5 over 4. And that'll be 4 over 3, right? Just taking the reciprocal of sine, cosine, and tangent. Right? Remember that? Okay. And then this big one here, sine, cosine, and tangent. Again, to figure that out, right? This is the angle, so the side opposite that angle is your opposite side. Hypotenuse is the longest side, and the side next to that angle is your adjacent side. Okay. Sine then is opposite over hypotenuse, which is 30 over 40 over 50, I mean, which is 3 over 5. Cosine is 40 over 50, which is 4 over 5. Tangent is 30 over 40, which is 3 over 4, right? Now, what do we notice? they're the same, right? The sine, cosine, tangent value is the same for both triangles. And the reason why that is because all six trig functions, they are ratios. Okay? So it doesn't matter how big the triangle is or how small the triangle is. If the ratios are the same, then they have the same value. So notice that 30, 40, 50, it has the same ratios as a 3, 4, 5 triangle, right? Between the sides. So we have the same cosecant, secant, and cotangent values as well. So they both belong to both of them. Cool? Yeah, so rate the trig functions are just ratios. All right. These two special triangles you guys have to know and memorize. It is your foundation for this whole trig, I think 3 chapters of trig. This is your foundation, right? Everything can be related when we learn some harder stuff, some more difficult things to understand, we can always relate it back to these two triangles. In particular, the unit circle, which we'll cover in a little bit. Okay? So if you guys learn anything today, memorize these two triangles and the ratio of the sides. Ratio of the sides are going to be across the 45 degrees is 1, across the 90 degree is square root of 2. That's the ratio of the sides. So, for example, if this was 5, then this is 5, and this would be 5 square root of 2. Okay, another way we can put it is I can label this as A, and then A square root of 2. All right? That's the ratio of the sides. Always in a 45, 45, 90. In a 30, 60, 90, it's going to be 1. Across the 60 degrees is square root of 3. Across the 90 degrees is 2. That's always going to be the ratio of the sides. So if I label A as 1, then square root of 3 is A square root of 3. 2 is 2 times A. Okay, those are your ratio of the sides. Okay? So now knowing that, we're going to fill in this. We're going to fill this in. Okay, the theta in degrees, in radians, and all the 6 trig functions of this. So, what is 30 degrees in radians? Pi over 6. What's 45 degrees in radians? Pi over 4. 60 degrees. Pi over 3. 90 degrees is pi over 2. Right? And these are essential for you guys to memorize as well. Okay? That you know that when it's over 6, it's going to be 30 degrees. When it's over 4, it's going to be 45. When it's over 3, it's 60. When it's over 2, it's 90. Okay? And today what we're going to do is we are just going to fill in these 3 rows. Okay, later on, we're going to fill in the 0 and the 90, but So in terms of 30 degrees, or in terms of 45 degrees, let's do 45 first. Okay, using 1 square root of 2, this is my opposite, this is my adjacent, and this is my hypotenuse. Sine is opposite over hypotenuse. So the sine of 45 degrees is 1 over square root of 2, correct? If it's 1 over square root of 2, then I can rationalize the denominator by multiplying this by square root of 2 over square root of 2. Rationalizing the denominator just means that I want the square root out of my denominator. Okay, I don't want a square root in my denominator, so 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. So sine of 45 degrees is 1 over square root of 2 or square root of 2 over 2. Cosine of 45 is 1 over square root of 2 again. So I'm just going to write the square root of 2 over 2. Tangent, which is opposite over adjacent, which is 1 over 1. 1 over 1 equals 1. Okay. Flipping sine to get cosecant. And the reason why I put this here is because it's easier for us to take the reciprocal of that than to take the reciprocal of the rationalized denominator one. That makes sense? Yeah, so if I just flip 1 over square root of 2, that's just square root of 2. Secant has the same value as, or cosine has the same value as sine, so the reciprocal is the same as well. Cotangent, the reciprocal of tangent, 1 over 1, the reciprocal of 1 over 1, which is 1, which is 1. Yeah. Cool. Sine, cosine, and tangent of 30. So if this is my theta here, the 30 degrees, then this is my opposite side, this is my adjacent side, and this is my hypotenuse. Sine is opposite over hypotenuse, which is 1 over 2. Cosine is adjacent over hypotenuse, which is square root of 3 over 2. Tangent, let me write it here because I have to rationalize the denominator, equals 1 over square root of 3, which is square root of 3 over 3. If I multiply both sides, let me do that for you guys. If I rationalize the denominator and I put square root of 3 over square root of 3, 1 times square root of 3 is square root of 3 over square root of 3 times square root of 3 is 3. So this would be 1 over square root of 3 equals square root of 3 over 3. Okay. Cosecant is the reciprocal of sine, which is 2. The reciprocal of secant is 2 over square root of 3. Hopefully you guys picked up on the pattern and I don't have to show you guys how I rationalize that denominator. It's going to be square root of 2 or 2 square root of 3 over 3. And the cotangent, take the reciprocal of tangent, the 1 over square root of 3, which is square root of 3. Make sense? If you guys got these two, the 60 degrees is easy. And I'll show you guys why. In red, in blue, or in red, if this is now my theta, okay? From the purple markings, the opposite, adjacent, and hypotenuse of the 30, what changes? So let's think about it like this. The side opposite the 60-degree angle is my opposite side, right? The side next to my, or this is still stays as my hypotenuse, right? The longest side still stays the longest side. And the side next to the theta 60-degree angle is my adjacent side. So what changed? My opposite and adjacent changed, correct? So if my opposite and adjacent side swapped in terms of the trig values, what switches? What changes? Opposite and adjacent swap. So in terms of my trig values, sine, cosine, and tangent, what changes? What flip-flops? This, for example, the sine of 30 degrees equals what trig value of 60? The cosine. Because look, opposite over hypotenuse, right? Of 30. That's the sine of 30. But in terms of 60 degrees angles, that's adjacent over hypotenuse. Right? So all I can say is, or what I can say now is that 1/2, which is the sine of 30 degrees, is the cosine of 30 degrees, of 60 degrees. Yeah? They flip flop. Okay? Same idea goes with the cosine. The cosine of 30 now is a sine of 60. If you look at the triangle itself too, you can figure that out. Looking at the red markings, right? Opposite over hypotenuse, which is square root of 3 over 2. Yeah. So my cosecant and secant flip-flops as well. So this is 2 square root of 3 over 3, and this is 2. Tangent is opposite over adjacent. Cotangent is adjacent over opposite, right? Opposite and adjacent is what flip-flopped in terms of 30 and 60, right? So the cotangent of 30-degree angle is the tangent of the 60-degree angle, and the tangent of 30 is the cotangent of 60. Does that make sense? Because the opposite and adjacent flopped, right? They swapped. The sine changes with the cosine, and the cotangent changes with the tangent. Okay? And I'm trying to bring a new element to your learning of these things, elevate your idea that you guys already know, right? Okay? Cool. Using a calculator is simple. Okay? Depending on what calculator you have, we have the sine button here, we have the cosine button here, and we have the tangent button here. Okay, I'm just hoping that you guys saw the screen kind of flicker, right? I can't write on this. But yeah, sine, cosine, tangent. Okay. So if I wanted the sine of 36 degrees, just put 36 equals, right? Cosine of 50 degrees equals. Okay. And remember, we also use the inverse, which you can push to second, sine, cosine, or tangent. That is used when you have the ratio and you're looking for the angle. Okay, so let's say you have that 3/4 cosine of 3 divided by 4. That would be the angle. All right. Okay. So that's how you would use a triangle or calculator. Solving a right triangle. We already know how to do these two, so I'm going to skip this. Notice in this batch of problems, we have special right triangles, right? We have 30 degrees here for number 15. So this is 60 degrees, and that's 90. Remember the value of the sides, the ratio of the sides, right? Across the 30 is A, across the 60 is A squared root of 3, across the 90 is 2A. So in order for us to figure out what X is, 2A equals 25, divide by 2, divide by 2, so A equals 25 over 2. So X equals 25 over 2. And we can simplify that to be what? 12.5. Yeah, that's it. We don't need trig. We're just using the triangles and their ratios. All right. Cool. Number 16, we have a 45, 45, 90. So if that's 45, then this is also 45. So that's 1, or that's A, this is A, and this is A squared of 2. So you already have your A value of 12. So I know that this side is 12. I know that this side is going to be 12 squared root of 2. We're done. Cool. Number 17, we have this. So I know that this is a 30, 60, 90. Opposite to 30 is A. Opposite to 60 is A squared root of 3. Opposite to 90 is 2A. So I know 2A equals 13. So my A value is going to be 13 over 2. Correct? So if that's 13 over 2, then this is 13 over 2. This would be 13 square root of 3 over 2. And we can just leave it like that. If you need the decimal value, then you can just plug it into your calculator. All right? Sounds good. Just using our special right triangle and their ratios. No trig is needed. Okay, for this one, 30, 60, and then 90. I know that this side opposite to 30 is A, opposite to 60 is A squared root of 3, opposite to 90 is 2A. So you have your A value at 4. So this is 4 square root of 3, and this would be 8. So X would equal 4 square root of 3. Done. And that's just using the ratios. And this time next week, these problems will be easy because you guys already memorized the ratios, right? Okay. Cool deal. The next problem, we do need trig. We do need your calculator. Okay. So in order for us to solve this, we need to label my sides first. Okay, we have 36. So this is my opposite side. This is my hypotenuse. And this is my adjacent, right? Now look at what we have. We have 12, which is my opposite side. And we have to figure out what x is, and that's my adjacent side. So you're going to think, what trig value deals with opposite and adjacent? Tangent. So the tangent of 36 degrees equals 12 over x. When your variable is in my denominator like this, right? All we're going to do is we are going to switch places between the x and the tangent of 36. So x is going to equal 12 over the tangent of 36. Okay? And you're going to go to your calculator. 12 divided by the tangent of 36. Make sure that your calculator is in degree mode. There's also a radian mode. You guys see the rad? That doesn't mean that my calculator is rad. Tubular dude. It just means that it's in radian mode. So every number that you plug in with the tangent or cosine or tangent or sine, right? It's going to read it as a radian. Okay. On your iPhone, or if you guys have this as your calculator, as long as your screen is clear, you're in degree mode. If you have another one, you have to go and click through your modes and make sure you're in degrees. Okay. So if we enter that, that would be 16.517. So your answer would be x 15.517. And that's it. Okay. All right. I'm just going to do a couple of these. Let's do actually just one of each. Let's do 26. So number 26, we have to sketch a triangle that has the acute angle theta and find the other 5 trig ratios. Okay? So oh, that's not it. It's not doing it. So let's say that this is theta here. Tangent is, what is tangent? Opposite over adjacent. So this is square root of 3 over 1, right? If the tangent of theta equals square root of 3, it's square root of 3 over 1. Automatically, I know what this side is. What? What is it? Square root of 3, 1, square root of 3, 1. If you don't know automatically, then you can use the Pythagorean theorem. Okay? Remember, the Pythagorean theorem is a squared plus b squared equals c squared. We have our a and our b. We have to figure out what c is, right? And c is your hypotenuse. Yeah. Or we can remember the special right triangles we just covered. And if it's 1, square root of 3, what's the other side? 2. Yeah. And then from this triangle, you can figure out all 5. Okay. 27. If I have a triangle like this, and I have this as my theta, cosecant, that's hypotenuse over opposite, the reciprocal of sine, right? So if cosecant, I'm on this problem here, 27. So if the cosecant is 11 over 6, this is my opposite, this is my adjacent, and this is my hypotenuse. So this would be 11, and this would be 6. Correct? In this case, we do need our Pythagorean theorem to figure out that last side. So 6 squared plus b squared equals 11 squared. How do I know 11 is my hypotenuse? Because it's opposite than 90 degrees. Okay? It's always going to be opposite than 90 degrees. So that's 36 plus b squared equals 121. Subtract 36, subtract 36. B squared equals, what would that be? 84? 85? So B equals the square root of 85. Is that? No, let's just put it like that. Oh, that's not it. So this side would be square root of 85. Okay, and then from these side lengths, you can figure out the other five trig values. Okay. Any questions here? No. Moving on to our last one. This looks confusing, but it's not. Because we already got all of these values. Yeah. What's the sine of pi over 6? 1/2. So this is 1/2. What's the cosine of pi over 6? Square root of 3 over 2. This will just be 1 plus square root of 3 over 2. Okay. What's the sine of 60? Square root of 3 over 2 squared plus the cosine of 60, 1/2 squared, which would be 3 over 4 plus 1 over 4, which is 4 over 4, which is 1. Yeah. Okay, so we just figure it out, plugging in the values that we know. Cool? Questions? No? That is your lesson for today, class. And that is 6.2 on the trig of right triangle.